So we have Dr. Muddassar Rashid today, and we're going to be talking about quantum physics, quantum mechanics, and that whole realm. Dr. Muddassar Rashid is an experimental physicist, and he's currently a postdoctoral researcher at King's College London. He did his PhD in the University of Southampton and his master's in Photon Science. The list does go on. He was the former chairman of the Ahmadiyya Muslim Research Association, AMRA, as well. And yeah, welcome to Hakam Inspire.
Thank you for having me. I'm really happy to be here and excited.
It's really nice to have you with us, Dr. Muddassar. So you've done a lot of research in the field of physics. Let's start with something simple, quantum physics. What is quantum physics? Yeah. Give us a kind of brief explanation, and how does it interact with our day-to-day life?
So, the definition of it, right? It's just a theory. It is actually one of the most accurate or precise theories we have to try to understand nature. And it tells us about what the properties and how atomic and subatomic particles move and behave. And from there, we can start to sort of understand the laws and come up with new laws of mechanics, essentially, that are governed at the fundamental reality.
Okay. Sorry. So how is that different from what we understand already? And so to someone who knows nothing about it, how would you explain how that has an effect on reality or nature or our world?
So it's really hard to relate to.
Yeah.
Because that's the first thing you have to
think that's what it is. People just kind of hear it and then just ignore it.
And often it is, you can't truly understand it because not in the sense that we really understand how gravity we feel gravity, right? So we understand how it works. It's pulling us. It's a pulling force.
Yeah.
It's difficult to understand what's going on at that level. So we have to use analogies to try to understand. And there are various peculiar effects that start to happen when physicists started to do experiments with atomic and subatomic particles. And so one of these effects, which is actually prevalent in technological development as well for us, is the concept of superposition. Right. Okay, and this is also nothing new. It's something you and I are so familiar with, we don't even think about it. So waves, noise that's coming out of or acoustic waves that I'm generating through my voice, or what you're hearing through the mic and everything. These are just waves, that are emanating through space and air. And so these waves are actually adding and subtracting at the same time.
Right.
And this phenomena of adding and subtracting of waves is known as superposition.
Right.
Superimposing on each other.
Yeah.
So you can have places. So, for example, concert halls are specially designed so that where you sit, you have maximum chance of hearing those waves.
Like exposure to the waves. Yeah, fine.
But you can sit in certain positions where the noises are cancelled out.
Yeah.
And so they're often really they're designed with certain geometric factors in mind of how waves will sort of hit them and diffract and reflect and interfere.
So it's interesting you mentioned that. I remember once I was in Washington.
Yeah.
We were in one of the buildings, I think it was Capitol Hill, and the tour guide was telling us that they used to be, so it was in a hall, there was the dome, and they said that sometimes people would spy on a conversation happening across the hall, but there's a particular spot where they would have to go and they could hear the conversation, even though they were 10 meters away or even more. And even if they were whispering.
Yeah.
So that's really interesting.
Yeah. And that's really the power of this principle of superposition. Right. And another adjacent concept, coherence, but maybe we won't talk about just yet. But now, what you might think is, okay, well, why are you talking about this? What has this got to do with atoms and electrons and protons? But it turns out that when you start to do certain experiments with these electrons and protons and so on, they start to behave. The only conclusion we can gather from the results of these experiments is that they must be behaving or be of some sort of wave.
So this is interesting because this is kind of if going back to kind of what we studied in school, solid, liquid, gas, you're saying that atoms and particles, what we learned about with the nucleus, the protons, the neutrons, and then your electrons, they're behaving like waves, is what you're trying to explain, is it?
So, what is something? We've gone very quickly into metaphysics here, but what is something? Is the electron a wave or a particle? And at the juncture of when you're carrying out the experiment, it's neither and both.
Right.
It's neither and both.
Yeah. So you can't say that it's a wave or a particle.
Right.
All you can say is that there's a wave of probabilities associated with the position of that electron. Yeah. So imagine a very simple experiment that maybe many of us would have done at GCSE science classes and so on. You have a light, right, and you shine it through some slits.
Yeah.
And on the other end, what you see is an interference pattern. So there'll be points where you see fringes, where you see light, dark, light, dark, light, dark. And that's basically light behaving as a wave.
Right.
Light waves have interfered with each other, and there are positions where they are dark, and there's position, i.e. there's no light there. And there's positions where they're bright.
Because it's gone through the slit.
The slit has sort of created, it's expanded the wave, and the waves have sort of collided together to create these points in space.
Yeah.
Now, a long time ago, someone called Louis Dubois, just a PhD student at that point, in his thesis, he associated with every single particle, even you and me, in principle, he argued, should have a wave function attached to it, a wavelength attached to it. So, you know.
So wait, sorry. I'm sorry for disrupting there. So you're saying particles are essentially waves.
They can behave as so.
They can behave, or
they are.
They are.
They are not waves as such, but they behave as such.
Right. Okay.
Yeah?
They behave.
And this is the way to see it, because this is where you have to take away. Sometimes it's the limitation of our language, and this is where mathematics is more liberating in describing what's happening. But in a way to understand is that there's this period of ignorance that's happening. Right. So now, in the same example of slits, let's say, you'll come to understand a bit better here. Yeah. Let's start firing a single electron through it, and you optimize the slits in a certain way. So now, what you find is that, of course, if there's two slits on the other end, you should expect just two bright spots, referring to where the electrons have arrived. Right. Yeah, and everywhere else you see nothing because electrons haven't arrived there. Yeah. But actually, what happens when you optimize these slits, you get a fringe pattern. Right. That's not just two; it's multiple. And the only way,
so they've expanded, basically.
The only way is that for every single electron that's going through, it's not going through one slit or the other. It's going through both at the same time.
Oh.
Wow. Okay.
That's pretty interesting. Now that's hard to wrap around, because you're thinking of something that's concrete and that has a defined size and is a particle, because that's how we see it. But at this point, it's to think about that. The only way to explain this is that it's really its position of where it is a wave of probabilities, and that probability is infinite in extent, by the way. You know, so the particle as it leaves, without being seen, and this is also another really important part. It so no one observes it. As long as no one observes it before and only observes it afterwards, you find that it's gone through all the possible paths that it could have to arrive at these points. And so it's in a superposition of all possible locations it could be in. Yeah.
Is that only with electrons?
No.
Can you...
So this is also the next natural question is, where are the limits of it?
Yeah.
And this has actually occupied me as a A-level student when I first came across this. I feel very, very blessed, and you might call it luck in some way, but also I would say it's the blessings of God that given me the opportunity to explore this. As an A-level student, I came across this phenomena, and I was just mesmerized. I couldn't stop thinking about it day and night. I wanted to be an engineer, and all of a sudden I come across this, and I just I'm going to go and study this. This is the fun stuff. So it turns out that people have done this experiment with larger and larger objects, the world record right now is by someone's group called Marcus Arndt. He's at University of Vienna, who was actually a previous supervisor of my supervisor.
Right.
So I then went on to do a PhD in Southampton, where we were trying to build a setup that would try to do this superposition experiment with larger objects, like with nanoparticles. It hasn't been done. No one's done it yet. But the largest object that's been shown to exhibit this property is about 20,000. So a molecule made up of 20,000 atoms.
Oh, wow.
Okay.
And it's behaved in the same way.
It's behaved as a wave.
So is that because of the electrons, or is that because of?
No. So the electron is just an example I'm using.
Yeah.
You know, so even light, for example.
Yeah.
You know, we always believed it to be a wave. You know, and Newton, for example, going all the way back, was an advocate of light being a particle. Yeah. But the reason he was disproven is because they were able to do this interference experiments of sorts and show that actually light behaves as a wave. But quantum mechanics reverses that and says, well, actually, light also behaves as a particle. Okay. So now all these fundamental things, they both have this property of being able to behave both as particles and as waves.
Okay, let's stop it there. And in terms of the superposition element, tell us about entanglement.
Okay. So entanglement is a more stronger statement of this sort. Yeah.
Okay. Because this is crazy. When I was reading about entanglement, the element, which obviously you can explain much better, of where two things, even if they're at one end of the universe, they will have the same I don't know, is properties, or they would act in a similar way. That's the element which I find it fascinating.
It's so you have to understand that everything I say is partly through the lens with which I view things, and there'll be others that will present it in a slightly different way. The experimental result is always the same. It doesn't matter what interpretation you take. So it's a disclaimer for the listeners and for you guys as well, that there's a bias in my mind, very likely. But essentially, the experiment you're talking about is, let's say you have two spins. So this is a property where two particles can have something called a property of spin, which can be up or down, let's say. And they come and interact, and then they go far away. Now, if you were to measure the spin of this, so this is done with photons, for example, with one, the other one will automatically be down. So if this got a spin up, the other one spin down. Now, this is where it gets interesting, because this is the big debate, saying, well, okay, how are they communicating? Now, you might say, well, okay, maybe there's a speed of light communication between them. It's fine. Well, what if I take them away so far that it would take longer for light to travel than the information of this should be, down or up? And you can do that. The result is still the same.
Interesting. Okay.
So that means that there's some sort of information being transferred between them. Now, there was a guy called John Bell, and he came up with an inequality. It's basically an idea, a test of this idea. And he said that if for example, quantum mechanics, so this is the effect of entanglement, is really true, i.e., it would mean that reality as we know it is non-local. Okay. Yeah. So local meaning essentially that communication is bound by relativity, by the speed of light. Okay. And he tried to get rid of all these other ideas that, for example, you can have extra dimensions, or there's other forces being acted that we don't detect, that this communication is happening, because no one understood why this communication is happening. And the tests and the experiments that have happened had led us to believe now that really there is no such thing as locality for these systems. They are so coupled that you can't tell the difference between this particle or this particle. When you talk about this particle, you have to talk about this particle. It's like like a string that you have to untwine. It's untwineable in the sense that
you can't detach
the two. Their identity is so that you can say that they're so entangled that they are one identity.
How are they entangled?
Yeah.
Has
So
that question been answered?
Entanglement always happens, and it's constantly happening. It always happens through an interaction. So they have to be.
Oh, okay.
They have to interact
interact
in some form, or they have to be spun out of the same source. So, for example, you can have special crystals that, if you shine light, will emit two lights in opposite directions.
Right.
This is just a feature of polarization. It's very common in optics to use this, but you can do it at the quantum where you send single photons, and it sort of entangles the ones that it's sending in two different directions. Yeah, and so that is because they've interacted at the same point, and they've now gone away.
Okay, so that's mind-boggling. You've done some research on the Holy Quran as well, and you've got some theories, and you did a presentation at the Quran Science Conference in 2020, was it? 2019. It's available on YouTube, and we'll link it below as well in the YouTube description. Tell us about that.
So this really is. So I have to give you a disclaimer again.
Yeah, of course.
This is really just series of discussions that happened with various friends within the community, some scientists, some very well versed in the Quran or literature in general. A lot of it is trying to understand what the fourth Khalifa of Ahmadiyya was talking about, and he gives very detailed understanding of a specific verse of the Quran. This is it's in chapter 24 and verse 36. It's called the Ayat Al-Nur, so the verse of the light. And in here, God sort of tells people about. It's a very metaphorical. In often the translations to this are in relation to how revelation descends upon the Holy Prophet of Islam and how God gives him that. But it also has this really interesting connection that I felt was there, and with the nature of light itself. And I've been musing about this for a very long time, and I was thinking about how light, for example, might exist in the universe here.
So just to clarify, the verse starts off with Allah is the light of the heavens.
Exactly. Yeah.
Okay.
And so do you take that literally, or do you take that metaphorically? And there's different levels to it as well. So the fourth Khalifa of Hazrat Mirza Tahir Ahmad, he explains that, well, it's talking about Nur. Nur is a much more encompassing concept, where exactly how you have visible light and you have different spectrums, in the same way you have light of God, which has different spectrums of his attributes encoded in it. And so this started this, and at the parallel to this, I still think a lot about the nature of this wave or particle duality, and what is a thing, what is the nature of something. Like an electron, is it truly an electron? How does it know it's an electron? Where is it encoded that it should be an electron? And the fact that actually electrons can change. So particle accelerators, you bang them together and you can change that. If you pump enough energy, you change their very nature to something else, right? So there's this transmutability about very fundamental things. And so what is there? So I think the Arabic word is wujud. What is their existence? How do you define them? How do they define themselves? And this is a parallel thought that's going on. And so then I felt that there was a strong link between how the verse talks about how light descends into this kind of oily fabric of reality. And in there's a cavity. So cavity is a really important concept. Generally, it's to amplify often light. But here, exactly, that's how God explains it, that there's this light that descends onto this material fabric, which has a very special quality that not only amplifies the light of Allah, it also has a connection with some sort of bubbles or light, a sort of confinement of some sort to this light to give it shape, to give it form. And then from there you get light upon light. And often there is this understanding that even our soul or our nature is connected with light. So within the light of God, the idea was that you have information about not only how something should be, you also have you have the energy to make it be. And this also then goes to another idea, which this requires like half an hour to an hour, maybe a day to explain. But it's a really important idea, which is that kun fayakun is also a phrase in the Quran, which is used. Allah says be and it becomes, it bees. And this is, well, what is Allah saying? He doesn't speak in the same way as we speak, but actually it's a thought. The thoughts of God are like him speaking and doing at the same time. And that thought is the light that reaches us and is in itself has all the energy, the ingredients.
Or even thought it could just be in the intention.
Yeah, exactly. Yeah. It's all the same thing in that sense, I guess. So that in itself has that. And there's a really interesting thing you can think about. And okay, so once again, disclaimers that this really moves away from science. Science does not refer to this, right? And this is a bit metaphysical, but close your eyes. Think about something and try to sustain that thought. Create a universe in that thought so that you don't know anything about it. That universe that you've thought of requires your own focus, your own, its sustenance is through your own focus, your own energy that you're imparting in it. The moment you stop thinking about it, it's gone.
That's quite interesting.
And so you can think about us in some form, that we are a fleeting thought of God, that without his direct sustenance that is constantly there and needed, we cease to exist.
It's interesting. I do want to ask you before we close off. So the second caliph of the Ahmadiyya Muslim community, he gave this. This is an article which a radiologist, he's an Ahmadi Muslim, he wrote, and basically he talks about how in radiology you have certain imprints on bones within children if they're going through growth issues or whatever, but those imprints show on the bones. And basically he was just talking about, there's the second caliph of the Ahmadiyya Muslim community, he said that it could well be that because energy doesn't finish, it's always there, but it changes its form sometimes, the law of conservation of energy. He said that because when you speak, as you're saying, it's wavelengths, is it? When you speak, they come out. He said it could be that humanity comes to a point where they create an instrument, technology advances so much, where you can fine tune the instrument. And so he was talking about the radio basically at that time when it was invented. He said it could be that this instrument fine tunes to a particular age or fine tunes the air around it, and you can pick up the actual voice of the Holy Prophet Muhammad Sallallahu Alaihi Wasallam 1500 years ago, and we can hear his words as we read his words in the books of Ahadith, because the point that the second caliph was making is that
information is never
lost, and the energy is never lost. It's just about the form changes.
It's kind of to do with like the red light shift kind of similar principle, where you're looking and then you see what's happened far away in space has already happened so long ago, but you're seeing it now.
So it's kind of stars.
Exactly. It's kind of like a similar kind of. I think that was the kind of theory that.
And so this Ahmadi radiologist, he basically compared it to his field of work as well. How there's always an effect on something, and it's a really good article. People can read it on Al-Hakam. I just wanted to know your kind of view of, because you were talking about a lot about how everything's a wave, and just your take. How this, because obviously quantum physics, it's not fully understood, and I think that's the beauty of it right now.
So it's not that it's not fully understood. I mean, it is, as I said, it's the most accurate theory we have.
Right. Okay.
Right. So It is the most understood
Okay.
and the most tested
Okay.
theory that we have. But of course, there's still things that we don't understand, without a doubt.
Yeah.
And no doubt there are. I work a lot on the foundational questions of within physics in different areas, and I'm involved with discussions of scientists who are there, and we're pushing boundaries by asking difficult questions, testing for things that you would be like, well, why are you doing that?
Yeah,
you know,
exactly. That goes against science, or
not necessarily against science, but it's not necessarily. It's like looking for the fifth force, right? There's motivation for it, because there are suggestions or theories or models that suggest that it could be there to explain certain things. So science cannot. So there is a movement of certain people who would conjure up ideas and so on and just want to test there. But science normally moves forward with a question that can't be explained, so you need a new model to explain it. So this is just to set it up, but essentially, there are ideas that explore these boundaries. So quantum mechanics, there are open questions in there still, lots and lots of them. And we don't really understand what happens at the very fundamental beyond quantum mechanics. We don't understand how quantum mechanics interfaces with gravity. This is an open problem, and there are major problems. So, but in reference to information, this is also something. So there are lots of ideas. There are some ideas about how information is never lost. Of course, it's as important as the conservation of energy. So in the sense that there is conservation of information, but this is not a proven thing. It's just something that over time you expect to be the case. In relation to what the second Khalifa was talking about, as it stands, we don't have the scientific knowledge for that to explain something like that. Because what happens is that energy gets scrambled. So for example, so if we live in a completely deterministic universe, you could imagine that I have a supercomputer of another level that can calculate and understand where the wave is and the particles are, and then exactly where they were, and then you can work your way back. But quantum mechanics tells us that's not possible. As we understand it. So it might require us to think very differently about this. But as it stands, it's because information, for example, dissipates out and gets scrambled that it's not possible for us to descramble it.
I think that's really interesting, because there's so much that we don't understand. We're trying to, even time, for example, we don't completely understand time. It's relative, understanding information.
So I just want to add that if, for example, so this is actually something you can read in the fourth Khalifa's book, Revelation, Rationality, Truth and Knowledge, where he talks in extent about the concept of entropy. Entropy. And so this, I think, would violate entropy unless there's an
what's entropy?
Entropy is that the growth of disorder. So everything is in a state of constant entropy, so that there's no change in its order, or that it grows towards disorder. And so, in another way to think about that is that you have this perfectly assembled information, and then it gets collided with this air molecules and everything, and it gets dissipated out, so it becomes more disordered over time as it gets introduced to this larger thing. And it's as we know it, it's impossible to go back. Unless there's some additional things there that we just don't know, additional fields that are storing that information that's dissipating out, that we haven't discovered. And so then you can think maybe that's one route, to explore.
It's been an amazing conversation. I think everyone would have, our audience and listeners will really enjoy this episode.
Absolutely, and it's certainly been a really enlightening discussion, because it's not every day that you have, a physicist in a niche field where you're talking about kind of these theories, and it kind of takes you back to your own understanding of reality and thought, and how
Makes you think, yeah.
exactly, you live your everyday life. It brings in the kind of spiritual element as well, in terms of kind of, our souls and spirituality as well. So no, it's been really kind of a really good pleasure to have you on the podcast. Yeah, we should have you again, inshallah. Yeah, God willing.
Definitely. No, thank you for having me. It's been a pleasure talking.
Thank you for listening to the Al-Hakam Inspire podcast. We hope you enjoyed it. Visit our socials on Instagram, Twitter, and YouTube at Al-Hakam Inspire. And of course, subscribe to our YouTube channel and leave your comments there. We would love to hear your feedback and thoughts, so send us an email to inspire@alhakam.org.